Hello everyone. This is Raman from ARC India, based out of Bangalore. Welcome to the webinar. So this is under the banner of ARC Asia Industry Best Practices Webinar. Theme of the webinar is transforming industrial operations with IT automation and edge computing. So we have about 4 guest speakers. Patrick Arnold, research analyst from ARC Advisory Group USA. Amy So, specialist solution architect, Ansible Red Hat Asia Pacific. Andreas Spanner, chief architect, CTO office and global engineering, Red Hat Asia Pacific. Lindy Sabloff, co-founder and CEO of Grace AI. So before we start the webinar, I would like to thank Red Hat and my colleagues from ARC for being participating in this webinar, and also Red Hat supporting us for this best practices webinar. We have speakers from USA, Australia, and Singapore. The event is hosted from Bangalore. The moderation for this will be done from Bob Will, based out of Singapore. The whole duration for this will be about 60 minutes. One request to all of you, please put all your questions in the Q&A box. Do not put any questions in chat box. So please put all your questions in the Q&A box only. After all the presentations are over, there'll be a Q&A session which will be moderated by Bob, and he will take all the questions. Over to you, Patrick. Can you please take it forward? Thank you all.
All right. Hello, everyone. Thanks so much for joining us today. I'm Patrick Arnold, analyst at ARC Advisory Group, and my portion of the presentation will be focusing on setting the stage with some of the broader trends related to the topics we're covering today, as well as sharing some ARC research that I think you all might find compelling. And afterwards, we'll hear, of course, from the folks at Red Hat, as well as Guys AI, about how they are putting some of these ideas into practice. So with that, let's get started. So just a short word about who we are at ARC and what we do. The first pillar of our practice is advisory services. We have offerings geared towards suppliers and end users, and we've worked with many of the big names in industry, energy, and infrastructure. The second pillar is our research. We do global and regional technology reports, market data services, podcasts, webinars, and surveys. And lastly, we curate industry leadership and learning communities, such as our technology working groups and the events that we host across the world. So let's talk a little bit about the sort of topics that we're thinking about currently. So on the left is, sort of our ongoing research topics. And on the right, we have some new topics that we'll be paying special attention to in 2025. Some of those, just to highlight, virtualized automation, how the industrial edge is intersecting with AI and how people are applying AI on the industrial edge. How the industrial software development experience is changing, like with low and no code tools, and the many open standards groups that are gaining traction right now in industry. So now let's move on to some of the broader trends that we're seeing here. There is a significant transformation happening as IT enterprise technologies and frameworks are extending into OT spaces. And the hardware and platforms used in production are in turn becoming more IT capable. We have some ideas here like centralized visibility, edge compute, virtualization, adopting a more unified cloud-like experience. These are some ideas that are catching on in the industrial context, and you need to evaluate where they can enhance your operations. So I'm sure that we've all heard the idea of IT-OT convergence, and I would argue that it is more real and more relevant than ever. But it's more than just flipping a switch and dissolving the barriers that existed between the IT and OT worlds overnight. It's about taking all the good ideas that have already been developed and applying them in a way that makes sense for OT. When you think of integration between the operations environment and the cloud, this idea was once a novelty, and now it's gained pretty wide acceptance. So, I think we in industry can be more efficient, we can be more competitive by taking things like orchestration, system automation that are already standard in the IT world and make use of it in our own way. No need to reinvent the wheel. We just need to evaluate which ideas are a good fit. And when we speak of automation, that will lead into my next little point here. As the lines between the various technological domains are growing more blurry, I do think we need to be mindful of the different perspectives on automation. For many in industry, automation means the application of industrial automation equipment, PLCs, DCS, and so on. But there's also IT automation, which can include tasks like configuration, software versioning and builds, business process automation, development pipelines, and so on. And even then, nestled between those is the edge layer, which in many ways includes aspects of both domains. So we'll definitely hear more about how we can benefit from the different kinds of automation from the other speakers today. But for now, let's examine some recent ARC data that I think you might find interesting. This first one here, this data comes from the end of year technology survey that ARC does each year. And we're basically polling industry stakeholders from around the world and a variety of industry verticals. So we're getting a very, very wide perspective here on how everyone in general is thinking about the technologies that are transforming industry. And this question in particular was asking how extensively organizations are planning to deploy virtualized automation technologies, such as virtual PLCs, virtual DCS controllers. And this is looking at the situation in a few years' time, looking forward to future plans. And we found that almost half are planning to make significant deployments of these virtualized automation concepts, with many more of them incorporating them in an area or aspect of their operations in some way. So we can see from this data that some of the more IT native ideas that were foreign to industry years ago are growing in acceptance, and I think in the near future will become ubiquitous in the OT world. So let's take a look at some more data here. So this question was asking which applications end users are currently running or plan to run on industrial edge compute devices and platforms. And for this one, we actually have the benefit of asking the same question last year during our survey. So we can see where some things changed and how the broader industry is moving. Security is a very important edge application. We can see analytics, AI, and ML applications are very big as well. Some of the more foundational use cases for edge computing, like data pre-processing and protocol conversion, these were pretty consistent year over year. And another big jump in people using or planning to use virtualized or soft control in their processes, which I think aligns a little bit with the previous graph as well. And I think overall, we see that not only are more organizations utilizing edge computing in their everyday, but the applications that people are running are growing more sophisticated. So people are accessing and gaining value from their data and their assets in new ways, but you can only fully realize these benefits with a comprehensive strategy to manage OT, IT, and edge. So let's move on to one more graph here. So everyone is thinking about AI, talking about AI, and the question we wanted to capture here is, what is your strategy to make use of AI in the industrial context? So, I've highlighted some important areas on this graph, but go ahead and look through them all if you like. And I think the first two highlighted here speak to the importance of having a converged OT, IT, edge strategy. For the first option, you have this sort of classic model of cloud computing using, these industrial edge compute devices to collect your actionable data, perhaps pre-process it to make it more cost-effective to transport, maybe contextualize it to make it more consumable for whatever products you're using. And the second option is where you can start to do some very interesting things, where you train the AI in the cloud and deploy to the industrial edge. If you train your AI and machine learning, at the data center level, you can then deploy that onto the edge compute environment on-prem to access low latency machine learning inference, which really opens up the possibilities when you're talking about a factory environment where things are moving very quickly, and you don't always have the luxury of going through the whole latency of back and forth from the data center. And another call out there near the bottom, having a comprehensive way to manage your data through an edge software platform is one path to achieving value out of these ideas. And I'm sure you'll hear more on that from Red Hat in the next presentations, but I did have one last slide on that note. So I wanted to take a look here at some of the common challenges faced by the end users in our ARC communities, as well as some potential ways that we could move forward using the ideas we're discussing today. One of the more enduring challenges in industry results from the sort of hardware-centric, legacy model of one box to one function. And of course, if you need a different function, you need a different box, and sometimes your vendor doesn't have that box, and now you're in trouble, right? When you embrace a more open software-defined model, you can prevent the vendor lock-in issue, and you can really increase the flexibility of your assets. Upgrades can be very costly, updates as well, and it can stretch your resources when putting things back online. I personally have heard many stories of people with USB drives crawling into all kinds of places, trying to update the firmware on a device. But with a consistent centralized management plane, you can remove some of that burden by automating things like device provisioning, software and firmware updates, and better provide a way to monitor the status of your operations without having to go into the field as often. Legacy software is another issue. I myself have worked on some very old automation software, and especially with the current shortage of engineering and automation professionals entering the workforce, it's becoming unsustainable to teach people outdated language and processes. But with these modern orchestration tools, you can make use of new software while virtualizing some of the legacy workloads, and you can consolidate and distribute your software in a way that's most efficient for your architecture. And then, speaking of inefficiency, this and downtime, these are the enemies of any operations environment. So let's hear more from our next speaker about some of the Red Hat approach to some of these challenges. Thanks so much, everyone. That's it for me, and I would love to introduce our next speaker, Amy So, Specialist Solution Architect at Red Hat Asia Pacific. Please, Amy, take it away.
Thank you, Patrick, for sharing his sessions. Hi, everyone. My name is Amy. As you know, I'm part of the Red Hat Ansible Automation Platform Specialist. So I just want to talk a little bit on system orchestrations, about automating how we set up, deploy, and even manage distributed systems and services. It actually helps to tie up different hardware, software, and services to make sure that they all work together to meet specific goals. So in the OT and IT, and the Open Industrial Automations system, we have orchestration, which is one of the most advanced in IT areas like cloud computing, microservices, and even DevSecOps. So again, in this place, you can see that manufacturing actually faces a lot of constant uncertainty, shifted demands, system failures, and competitive pressures. So system orchestrations actually helps to tackle these challenges by providing a lot of flexibility, resilience, and even efficiency. So by automating this manual tasks, it actually helps to cut costs, cut errors, and even save times. Additionally, it helps to also support sustainability by optimizing those resource use. Next, I want to talk about, what exactly is industrial edge. So you can see in technologies that helps to enable manage data and system close to the source, such as we have aerospace defense, we have electronics, home appliances, we even have pharmacy, chemical companies, semiconductor, and food and beverages. Next, and I'm going to talk a little bit more on edge computing. What exactly is that as well? And what is the complex in it? So great opportunities along where it brings a lot of different challenges that helps to be careful, considerate. So such as we all do know security and compliance. It helps to protect sensitive data and meeting regulations while processing information at the edge for low latency decisions. We also do have skills, which is the management and skills. We have to handle hundreds to thousands of the edge nodes across multiple locations with very limited IT staff. And where we do have innovations that helps to support in-house innovative and also partnership with our third-party vendor providers. So lastly, we do have the complexity of infrastructure, helps to manage diversity with multi-vendors, increase costs, and will require special skills need. So this is kind of the key is to ensure the central management across different vendors, consistent operation so that developers can focus on application without adding complexity. So where I want to introduce next is Ansible. I'm not sure if everyone have heard about Ansible, which is a universal automation language. We often know that this is an automation journey, and it also helps to manage a wide range of technologies and systems. This actually is a very versatile tool to help to automate all kinds of tasks, including the platform. So Ansible acts like a translator between technologies and protocols, kind of like bridging the gaps to ensure everything works together seamlessly. And at the same time, it's not just for IT infrastructure. It also helps to be able to automate industrial systems like our PLC, which is programmable to logic controllers, using the common industrial protocols. So this capability actually helps to improve efficiency, like again I mentioned, reduce human errors, and also scales operations more effectively. So another approach, which is I'm going to start by introducing the key pillars of system orchestration. You can see on the left side is Ansible is the de facto of the language of the automations. So exactly, it is what it's supposed to be. It's human readable. It's in English, YAML. So you can don't have to require a lot of developers to start learning new skills. But of course, managing Ansible human readable and it's simple to learn. At the same time, Ansible automation platform is not really focused on one domain. You can see we are multi-domains, we are wide range, we do application, network, cloud, security infrastructure, and edge, which is what we are talking about today. So we have like industrial, IoT devices, automations, manufacturing on the remote sites management as well. So by leveraging Ansible, organization can actually achieve greater efficiency and reliability in their orchestration processes. So I talked so much about, Ansible automation platform, Ansible. So what exactly is Ansible? If you take a look at the current slides that I'm showing, is that on a brighter red, the control plane, where is all the Ansible automations platform and the heart of entire this controller, where it helps to manage your credential, encrypt, it helps to orchestrate. When we keep talking about orchestrations, all your manual tools, we have to integrate between all the different integration tools, such as, your different IT tools in your environment. It's a self-service, means that it's customizable flexibility that your organization can do. We also do have user management. This is the key components of the entire platform. So what is the user management? I just want to leverage on it more is that user management is a robust access control where you can control who can actually run your automation tasks and who have the access to update your automation tasks as well. And lastly, we do have auditing and logins through. So all this auditing and login is that in the sense that you have your auditors that comes in to see who actually last ran the job, who actually last ran the automation task. This is all being audited and logins in the entire control plane. So I just going to talk about, like automation mesh where it can sit at your different locations for edge. And we do have private automation hub where you can store your private automation collections, which is all your Git repository. So next here, you can see that like this, we have 170 certified content collections, which I mentioned earlier on. It's like a translator. All this, when we mention Ansible, it actually acts like a translator between different technologies. And with that, we actually partners with over 70 certified technology partners, where you can see all the different logos are there to help to manage end-to-end process, such as infrastructure, network, edge, and security. So before I want to go into that, I'm just going to show you next a little bit more about what exactly is Ansible. So you can see, I'm not going to go through everything, but you can tell, like what exactly is automations that we keep talking about. Just let's start with a very simple example. As you can see, it's rather short and consistent with 3 tasks. And this is what Ansible playbooks, where all your automations are doing. So the language itself is simple to grasp. Since it's carried tasks, it carries a name, a statement, everything is already partially documented here. So a value, just want to show you, quick to learn, low entry barriers, and no developer skills actually needed. So some of the example is like a network operations, want to understand this and read it. They don't have to train to, learn any aliens on their domains. So the ending key points is, what is the keywords like? YAML. What is the keywords like templates? So these are actually the collections that we are talking about to help to do the translations. So you can see this playbook is just going to talk about like, oh, I'm going to install and start Apache. And this is the few different steps that you can input to make sure that at your end managed nodes, at your endpoint, this is what it's going to do. Next, we are going to talk about, Today, everything we're going to talk is about edge. So this diagram actually shows how automation can reach every endpoint of the network, from the outer edge to the core. At the far edge, you have this like sensor gateways. Closer in, you have servers and the data center. And all these are all the way to the cloud. So Ansible automation platform with Red Hat helps to automate tasks across all these layers, making it easier to manage devices no matter where they are in the network. And then next is going to show you a little bit different, but it's the same because every components, if I'm going to talk through, it's going to take more than 1 hour to talk through. So I'm just going to high level, going to break down these examples. As you can see on the right side, I have the infrastructure edge. This is where the developers and the network management actually happens. For instance, a company uses like a GitHub to manage all their codes for edge applications. So again, next to the center, we have the distributed edge. This layer actually helps to handle all the automation tasks. For an example, an edge server in a retail store might manage inventory tracking systems. So it requires tools like components like SIEM, which is security management, SOAR to monitor threats, email registry to store like software updates, and network management to keep everything connected. So how does this reaches to their far edge? This is where devices like sensor, example, temperature sensor in a factory, or even a human machines interface, touch screens, or machines operations. So all these are actually devices need cloud connectivity to send data over the updates to stay current and firewall to stay secure. So Ansible automation platform can actually help to automate tasks across all these layers. So example again, it's just going to automate updates on sensor management, on sensor and manage security policy on edge devices, and even deploy new applications across the network. So I'm going to come to my last slide here, is that if you can see, we actually partners with Rockwell, Red Hat and Rockwell. We have a very strong partnership together. We are joint forces to bring smarter automation to the industrial world today. Companies in this space are always looking for ways to improve, whether it's in making a better product, reducing downtime, or even cutting costs. So what is the secret to make this happen? Using data from edge devices such as sensors and machines. By tapping into this data, businesses can actually make smarter decisions and streamline these operations. And at the heart of this effort, Rockwell, a top-tier process automation systems, it helps to actually collect and analyze data from edge devices, while Red Hat Ansible automation platform steps in to handle the automation tasks like server updates, server setup, maintenance, and even configuration as well. So this partnership actually takes a burden of routine work of the OT teams and then freeing them up to focus more on more strategic tasks and also ensure operations run smoothly and consistently. So together, right, just going to high level before I move on, this tool helps industry companies to modernize their processes, which is very important today, and making them more efficient, scalable, and future ready. So that's all I'm going to share. I'm going to pass to Andrews, which is going to share more about his use cases as well. Thank you.
Thank you, Amy, and thank you, Patrick. So the next session is going to put a bit of meat on the bone. Lindy from Guys AI and myself, we're going to run you through some use cases. Just a quick word to Guys AI. Guys AI is one of our long-term industrial edge partners. Really, I remember many years ago when AI wasn't as much a hype as it is today. Guys AI and my team already started working to get on some use cases, and Lindy will walk you through in more detail about that. The next session, I see the great questions on the chat, Davey. The next section also is going to answer a little bit about how common it is already in industrial automation. So just to summarize what Amy just said, right? When you hear the word edge, it's basically the Red Hat view of edge, and it can mean anything from your Purdue layer 1 to up to the MES or the ERP system, right? So, but I'm going to cover that a little bit more. So in terms of what Amy just said, what does automated system orchestration bring? Rapid onboarding, new controllers or servers could be deployed in minutes through deployment automation. And that's exactly what I just said, from level 1 right up to level 4 or 5 in the Purdue model. Then scalability and software lifecycle management playbooks. That's what Amy just showed in the code, right? That describe a software manifest. So in that case, she installed Apache, but it could be a code assist soft controller. Codesys software-based PLC, right, programmable logic controller. And if you have that source of truth as a playbook stored somewhere, then you can actually run that and deploy it consistently across your entire environment. And that is the next point, standardized deployments. So in summary then of that slide, automated system orchestration enables error reduction, increased efficiency, scalability, and robustness. And we as Red Hat are very keen to engage in any of those Purdue levels. If you have any use cases on the MES level, that's a great conversation to have amongst us. And if you want to look into software PLCs, then we also very keen to have this conversation with you and our partners. So on the next slide, then I just want to summarize what edge computing is today and what's already happening, and that also refers a little bit to your question, Davey. In telecommunications, of course, we all know about 5G and 6G now in development. We use NFV and vRAN, but today we really follow on the industrial use cases in manufacturing, energy, oil and gas, and for that, using predictive maintenance and software-defined PLCs, factory automation, distributed grid control in energy and substation modernization as well, and in oil and gas process control, environment monitoring, and autonomous vehicles. Autonomous vehicles is another topic that Red Hat covers with our Red Hat in-vehicle operating system, but that's outside of the industrial edge topic today. Okay, so let's move on and cover quickly. That's a quick detour. I don't want to make this a product-centric kind of section, but just to give you a surety that we have your use cases covered. So the Red Hat platform comes in many different form factors. So if you have a far edge device in that case, which is a small form factor or can be a small form factor, then we have you covered with platforms that drive and run small form factors. If you have server grade hardware on your production line or in your manufacturing plant, then we have you covered as well. So whatever your requirements are, our platforms cover those. Then in the next slide, I'm going to cover now the different industry verticals and what kind of software and workloads we're talking about when we talk about system orchestration. Obviously, I look after MSR, so there's also retail and automotive in there, but really logistics, energies, and industrial automation is the core today. And if you just look at the column under industrial, you have the embedded OS, you got software controls, HMI, human machine interface, you got the SCADA system, supervisory control and data acquisition, and MES, the manufacturing execution system. And those red bars really mean that this is what we can cover through Ansible automation to help with this consistency, to make sure the configuration, the security, the requirements, compliance requirements that Amy mentioned are basically covered. And you have the latest and greatest available in the single source of truth. So that's really the core of the message today. No matter where your challenges lie or where you want to focus on as a first trial, we can address that through Ansible automation. So the next slide then starts looking at the manufacturing example. So this is actually a real example from an automotive customer, but not the automotive part. It's actually the manufacturing part. In that case, we used automation for the industrial field device controllers like robots, punching machines, welding torches, and riveting guns. And if you click on the buttons, you see the slide building up, like the PLC, programmable logic controllers. As I said already, there's great interest in the industry to just try out for now how a software-defined PLC runs. And I have an example in the following slides on this. And then as a next example, you have, for example, the SCADA systems. Just the provisioning. In the most recent one, I deployed inductive automation SCADA system with a SQL Server database as a backend, and the configuration we could just package up in those Ansible automation playbooks and just recreate it every single time. And when I did my last ERP migration, for example, that was exactly one of the big problems, that when we had to switch from the test to the UT environment, that the configurations were always out of sync, and that costed a lot of time, effort, and rework every time. So that's kind of the core of that use case with the automotive manufacturers. And the next slide talks about a different use case or a combination of that, and Lindy might recognize some of those because we have actually worked with those. On the left-hand side, you see Ansible providing high availability for DCN, distributed compute nodes. So we simulate a failure. We have two DCNs running. We unplug one DCN, and then Ansible detects that error and basically switches automatically over and ensures that the water tank that you see on the left bottom that has the Intel and Schneider logo on it, that actually ensured that the tank always has the optimal water level. So those DCNs on the left-hand side were actually controlling that water tank in simulation of a process control environment. And then on the right-hand side, you see AI computer vision being used to label bottles and also to do a quality check on those labeled bottles. Okay, next slide then. We have one of the use cases we developed for the last ITAP. And what you see here might not look that impressive, but it's actually three different AI models talking to each other. It's a multimodal and multi-model use case. So multimodal means you have different models deployed, and multimodal means that you have different modes. Like, for example, you see the picture that comes through an RTSP stream. It looks at what's going on the factory floor, for example, and it does a security or safety equipment compliance check. And so it checks for a hard hat, for the safety vest, and the mouse mask, for example. And then at the bottom, the blue and the red bar show you a description of that. So this is then the detection will be moved on to a separate model, which is an image to text model. It describes the image. And then whatever the description is will then be fed into a real-time RAG setup. So RAG stands for Retrieval Augmented Generation, and it allows you to basically augment the LLM's capabilities and knowledge with real-time information or more recent information past the training data of this LLM. And what that allows the operator now to do is, in real time, as you can see on the slide, what is the hard hat compliance rate? And the LLM can give you the current state of the hard hat compliance rate. On the next slide, then we see the architecture of that. Exactly as I said, camera can be any camera, moves into the RTSP, or moves the RTSP video stream into in that case, a YOLO V8 model. You can use other models as well. We do an anomaly detection that then gets to a Gen AI model, image to text, Lava 30B, for example. And then the web interface is an application that talks to the Copilot type Merlinite 7B and RAG deployment. And at the bottom, again, I said earlier, we got your requirements covered, and that's the same with OpenShift AI. OpenShift AI is basically just an extension of AI capabilities on top of OpenShift. And the beauty is that you can run it anywhere you want on your Intel hardware, AMD, NVIDIA, public, private, hybrid cloud environment virtualization, or at the edge, right, if you have smaller form factors. And on the next slide, then, I'll refer back to that PLC, software PLC comment that I made earlier. So this is our SI, ATS Global has built that with us. This is really showcasing a Codesys software PLC programmed, communicating with the Brunner EtherCAT IO device that I have here on my desk still, and that then controls that miniature manufacturing plant. So there is no proprietary expensive PLC running anymore. It's basically a software programmable logic controller running on an x86 hardware platform running on Red Hat Enterprise Linux. Okay, then the next slide is basically a wrap up and saying whatever your deployment is, most likely you have multiple production lines, you have multiple sites or multiple locations even across the globe. And the management layer of our automation platform also covers basically the entire global estate in terms of automation. You have your central point of control, you have your playbook that Amy showed, and you then have via the management layer or the management components as you see here, like Ansible automation platform, advanced cluster management, and or OpenShift or Enterprise Linux, the chance to make this consistent across the globe or across all the environments that you want to have consistent based on policies. So you define policies and they then drive the automated rollout and configuration. Okay, then we're moving on to the next slide, which is Lindy's slide. So I hand over to Lindy, and Lindy, please take it away. Thank you.
Thank you so much, Andreas. I'm Lindy Sabloff. I am the co-founder and COO of Guys AI. We're a software company that, we are focused exclusively on edge AI solutions for enterprises. As Andreas said, we are actually, a longtime partner of Red Hat. Amy, we actually came in through the Ansible BU, as we were, the beginning of our company was actually focused on creating, very small AI models to run on very small compute. Sometimes, we could actually get them down to less than a megabyte running on a Raspberry Pi, to give an example of some of the amazing things you can do at the edge. But we needed to really be able to, deploy and manage and do all the orchestration as well for these AI models. And Ansible was actually absolutely integral to that effort, especially on the orchestration piece as well. And I like to joke that, we're kind of a walking advertisement for Red Hat, from Ansible to our AI runs on RHEL, to OpenShift, Quay, et cetera. As you really kind of think about the edge, you really need to think about a software and hardware ecosystem that really works for you. And as we built out our edge platform to kind of deploy, manage, and monitor, AI workloads at scale, Red Hat fit perfectly into that equation. So Andreas really set the stage, for us on what we can do, what the different industries are, and how we can start thinking, about edge AI. And there are numerous advantages to it, right? Low latency, data security, right? You're not moving your data, from where it's being created. You're leveraging it, right where the sensors are, the PLCs, et cetera. If you don't have wonderful bandwidth, this is very necessary. As AI keeps advancing, and edge AI especially keeps advancing, you're running these on CPUs, not GPUs. So you have a much smaller energy footprint for it, and especially, if you set your edge AI up properly, it can be very cost efficient. So bottom line, edge AI, is really designed to work incredibly well in resource constrained environments. And that can be, from the factory floor to, if you're thinking about energy, it can be wind turbines, and oil and gas, et cetera. But, if you're either beginning or you're continuing on your edge journey, you really need to carefully consider, what are you looking to achieve, with edge AI, but also, what's your topology? How are you set up? Where do you want the focal point for your data gravity to really be? We don't look at edge in a silo. Edge is part of the larger enterprise, whether it's edge to data center and back, or edge to cloud and back. It's being connected in different ways, right? Even if you're leveraging that raw data, from sensors, from cameras, et cetera, at the edge, you're not going to store all of that at the edge for the long term. And that's really where you need to look at your enterprise and how you want to operate. From computer vision to real-time predictive analytics, you need to have a keen understanding of where you're deploying, and how those AI solutions really integrate with your existing systems, right? So as you scale, you look at this slide, if you're one small retail shop, and you kind of move up to a manufacturing facility, to a large, multinational, global enterprise, and you scale from just maybe a handful of devices to thousands of heterogeneous of devices across, different geographies. That complexity increases, right? Edge has its own special needs. Security is vastly different at the edge when you're scaling horizontally versus scaling vertically in the cloud. And so you really need to pay special attention to data at rest and data in motion. And also just the devices themselves, right? You are talking about small compute, small devices. You can put a Jetson Nano in your pocket and walk off. And so you really need to understand the security aspect of it and make sure that you're setting it up in a way that fits your needs. So just as you think about instituting an edge solution, I'll encourage you to think really carefully as you implement it. And the four kind of core tenets that I always think about are flexibility, scalability, security, and interoperability, right? Was having a conversation with a customer one time, and they were like, "Hey, we're doing predictive maintenance. We bought this solution," and then he starts to kind of trail off, and I said, "What's the problem?" And he said, "Well, you know, they gave us the sensors, they gave us the, they gave us the software," and I said, "They think your data is their data, don't they?" And he goes, "Yeah." And I said, it's not interoperable, right? He's like, "Yeah, it's not connecting with our SCADA system." And I said, you need to think about these things. You need to think about what, how it's going to integrate, with your existing systems, right? You need to be able to easily add that layer of intelligence to your existing infrastructure. And that's not just from a hardware standpoint, that's from a software standpoint as well. So unless you're building, a new state-of-the-art facility, I like to joke that most greenfield opportunities have brownfield roots. So you need to be able to simply add and subtract devices, and you need to be able to deploy and upgrade AI use cases. And not just upgrade, but also monitor, right? AI is not set it and forget it. As much as we would love it, models degrade over time. You need to be able to monitor them and really look to see if there's any data drift. And if drift is occurring, you need to be able to retrain so that you can maintain the accuracy of the models, right? Models, if you're doing analytics, it's only as good as the data it's producing, right? And so you need to have an understanding of the needs of AI, as you put it out into the world. And you do need to make sure that it integrates, with any of your legacy systems. You know, Patrick actually, touched on some very important components of this, right? There are different protocols at the edge for different sensors, right? Yeah, you've got OPC-UA, Modbus, MQTT, etc. And so you need to figure out how to harness that data properly so that it's AI ready for inferencing on those devices at the edge. So there are a lot of different things out there, but really the beauty is that with the edge, while there are kind of disparate components to it, there is an absolutely incredible edge ecosystem that exists. And I think as the technology advances and you can do more with the AI, the systems, the infrastructure that supports it is getting better, alongside the improvements that you're seeing in AI as well. Gareth, if you wouldn't mind going to the next slide. I'll stop yapping, and now we can have the fun and really start looking at some of the sample videos. There are lots of things you can do. I think the obvious use cases that a lot of us think about are the computer vision use cases, right? From some of the ones that Andreas showed, the safety with the PPE gear, actually the demo that we had created together for visual inspection, to operations analytics. And just digitizing analog devices. So the video that you're seeing on the right of the gauge, there are so many analog gauges out there. You don't want to replace them all. In fact, it's impossible to replace them all. But as we modernize, factories and different, parts of our enterprise, it's really actually quite easy to modernize, with a simple, $30 USB camera, pointed at a gauge, connected to a small device, and then this is very simple, and it can connect right to any of your other software, or you can actually just build analytics off of it, and it's just a very simple way through computer vision to modernize your operations. And then what you see on the right is actually doing real-time analytics for airport ground operations. You've got about 18 different AI models running in there doing different types of detection. Some of it's safety, some of it's process, etc. And it's really quite impressive what you can pick up now, from doing things like license plate recognition, doing optical character recognition, reading letters and numbers, to the myriad YOLO models out there. I mean, my goodness, you can hop on Hugging Face and have a heck of a time. Gareth, if you wouldn't mind going to the next one and playing this video. So what you're seeing here is actually a complete, wind farm operations and analytics suite that we built out for a customer, where a number of things are going on. You actually have prediction of the wind that's going to be generated in the next 24 hours, as well as a complete insight into the health of every turbine within the wind farm. Again, it's about saving time and saving money, so that you don't have to put wheels in motion. Or if you know that, something is going to break, right? You've got your geared shift alert here that, the turbine is predicted to fail, in the next few days. You can keep something a small problem instead of allowing it to break, to fail, and to potentially become, a much larger problem. And really quite incredible, the advances of Edge AI and being able to run these models right, right where their sensors are, right, at the turbine level, at the wind farm. This is doing the real-time health of the turbines using anomaly detection on streaming data from vibration and acoustic sensors that are placed in the turbines. And it really puts the power of maintenance back in the hands of the operator. And again, it lowers the need for, to put wheels in motion. Also, depending on factoring or, especially, we mentioned chemical plants early on. There's a lot of dull machinery in there, but it's critical machinery. And if it breaks, and you don't have any kind of real-time insight into that, a lot of plants, shut down for, a few weeks every year, and that's when, you go through everything soup to nuts and look through it. But with predictive analytics, and predictive maintenance especially, you have real-time insights into all that machinery, right? So your factory is online longer. You don't have to take it down. Equipment boilers, for example, you want to make sure that these things don't break. Not just about keeping your factory online, but from a safety perspective, it's critical to really understand that. And so, just a couple examples that a lot of amazingly cool things that you can do. Gareth, if you wouldn't mind going to the next slide. One more, I think. Yeah, this one. I'll just end with, the saying is, it takes a village to raise a child. I like to say it takes an ecosystem to build an edge solution. So thank you all very much.
Thank you very much, Lindy, and also to Patrick, Amy, Andreas. And joining us as well for the Q&A session, we have Dr. Arnaud Buissin. He's also with Red Hat Asia Pacific here in Singapore. So bonjour, Arnaud, to you. I can see we have quite a lot of questions already. So let me not waste too much time, and let's see how many of those we can get through in this session. Okay, so question: how do legacy and proprietary protocols, how are they handled by the Ansible platform? Who would like to take that?
I can take that. So
yeah, sure.
We actually have a development on the Allen Bradleys, and so there's an Ansible. There's a blog post out there that you can look out for. It's called the How to Automate Devices Using the Ansible CIP Collection. And so that's a great demonstration of how Ansible modules can be created to actually understand proprietary protocols. If that's the way you want to go down to, the other way is to so first of all the controls providers are gonna or are working on some software-defined API-based or automation interface anyway. But that's one way to create specific Ansible modules that understand the proprietary protocol. Or you look at software-defined sort of approaches as well to replace them outright. So whenever new technology or new production lines come online.
Okay, thanks, Andreas. Okay, this question is about with increasing edge computing, how do we maintain the speed of data exchange, especially when we want to have integration of edge computing with software applications like MES or PLM? So how do we maintain that speed when we talk about edge computing with these applications? Yeah, Arnaud or Andreas, I guess.
Yeah, I'm going to start. I was very motivated during the presentation already to answer, so I started by text.
It's okay, no problem.
I can repeat it here and let Andreas finish. I think it's a very large subject because you can have a lot of very different situations. Now, basically, when we talk about data in the factory or at the edge, this is really one of the main reasons why we see IT arriving and connecting to OT. It's because where OT is dedicated to operations, IT is really dedicated for tens of years to the data. And bringing IT solutions to the shop floor, to the factory floor, is really bringing the solutions that are done and are have a lot of background and experience on data to the factory floor. So providers from IT, including Red Hat, especially, are bringing solutions to make data exchange, like Kafka, for example, or MQs and queues for exchanging message, or for high volume data exchange, also providing a software solution for the storage in link with our overstack, and so on. Now, if you want a more architecture-oriented solution, I will let Andreas add his flavor.
Yeah, just quickly, +1 what Arnaud said. And so when we work with manufacturers, we actually look at their architectures, right? Sometimes we deploy like gateways in their production networks and then get the data out if that's appropriate. You can apply federated learning setups where you basically train the model at the edge and not send all the data around, so that reduces data volume. Or you have data mesh architecture. So you know, it's often a mix of different approaches, but it's definitely a topic I'd like to discuss further if that's available. Thank you for the question. Great question, by the way.
Yeah, thanks, Andreas, for clarifying that point, along with Arnaud. So I would expect today that we have a very OT-oriented audience. So I would have expected this next question, and indeed, I can kind of see it here. So the question is, will Ansible replace the existing control automation ecosystem that is dominated by PLCs? So is there any threat with everything that you're saying today? Is there any threat to the existing control and automation brands?
So
if I can start answering on that, I would like to come back to what Amy was saying regarding the difference in the wording of automation. So when we say automation, we can talk about industrial automation, which is automating the industrial process that you use to build a product, for example. When we are talking about automation with Ansible, it's IT automation. This is the automation of the IT activities. So we are not talking about the same thing. And you can have on one side your PLC, standard PLC running in your factory, and you will use Ansible to deploy a new software on it, to deploy a new firmware, for example, to stop or restart a software or a PLC.
Okay. Yeah, because in fact, Amy gave the example of your collaboration with Rockwell Automation on the Plant PX. So I think that's a good indicator of how you're actually working together with these automation companies. It's not something that is a competitive situation.
Yeah, absolutely. Now, what we see also is industry automation controls are taking a move towards software-defined controls, where we see the start of a separation between the hardware and the software, and much more flexibility on the software. We are talking about touching that point also earlier in the presentation, but that's a different subject. It is connected, but different subject. And this one is definitely revolutioning the way we are creating, designing, deploying PLCs in manufacturing.
Okay, thanks. Thanks, Arnaud. I think this question was touched lightly during one of the presentations, but it's can you please share which particular industries are using the Red Hat solutions that you presented today? So perhaps a bit more information on which industries within your MSR portfolio.
Yeah, I will start with that and let also Andreas and Amy add something. We have a few very interesting references. The very first that Amy mentioned is Rockwell Automation. So Rockwell Automation is now integrating in their solution to deploy to their customer or in the factory of their own customer to deploy their solutions, to update the solution, to maintain the solution. They are now embedding Ansible into their offer. So from now on, when you use Rockwell Automation in your factory on a distributed environment, Ansible might be under that. That's a first answer to that. Now we have huge deployments in mining, for example, in mining sites to update and patch all the different OS that are there. And we know how much it's difficult when you have a very old version of Windows to change that and to move to something else. But then there's a huge value when you have this context to have a centralized, uniform platform to update all the different OS you have, whether they are Red Hat Enterprise Linux from our company or any other Linux. So that's in that. I'm sharing also at the same time an example on industries in process manufacturing and also about DCS maintained and updated with Ansible. We have a fun video, and I'm sharing that in the chat right now for you guys to use.
All right. Okay. Okay. Great. A question about how Ansible fits in with industry-specific platforms and initiatives like Namur or OPC-UA-based open architecture, or even the OPA initiative. Can you say something about that? And where does it fit in or into those kinds of initiatives in the industry?
Yeah, so we very much compliant or working with those standards. There's a larger movement, OPAF, for example, the Open Process Automation Framework, and the OPAS community behind it. So we pretty much for those open standards, and we actively supporting them.
And you're also part of the Namur initiatives.
Right, and also with the OPA as well. Is that Red Hat is also
Namur? No, I see also mentioned on Namur. We are part of the Namur initiative too.
Okay. Okay. There's a question here. I know you mentioned quite a number of Red Hat technologies. So really about clarifying where do OpenShift or Microshift edge technologies, how do they sit within or relate to the Ansible platform? I think
Andreas,
Arno,
you want to take that one?
Yeah, that's pretty much as Arno already typed
Yeah.
in as well, right? So it's basically complementary. So while the platform like Microshift or Red Hat Enterprise Linux or Device Edge or OpenShift would run the actual workload, Ansible would be helping to deploy the infrastructure, make sure it's all consistent and compliant and secure. That's kind of the so it's basically perpendicular to the platform offerings, right?
I just want to give a question to Patrick. And I know you went through quite a number of surveys in your presentation. Was there one particular thing that stuck out to you? Was it either what you were expecting, or was there perhaps a surprise, or what did you get most out of that survey that struck you when you saw the results?
Yeah, a great question, Bob. I think one of the things that surprised me is, just how ubiquitous virtualized automation is going to be in the future. This is something that has felt like it's been in the works for a long time. It felt like it's been gaining momentum, but it hasn't quite, hit the big time. And to see that so many people were thinking about, applying virtualization in their operations, it really surprised me that that there's a much more bigger movement than we predicted.
Okay, thanks, Patrick. Well, that's a very optimistic future then, I think. We're getting into the close of this session, so let me just take probably one of the last questions. Very practical question. Is there anywhere I can get training for Red Hat Edge and OT deployments? Are there certifications for these technologies?
Yeah, that's a very good question. So the short answer is yes, but the long answer is the whole point of using Red Hat is the fact that yesterday's cloud engineer can be tomorrow's edge or OT kind of engineer, because the skills that you learn from Red Hat Enterprise Linux are the same that you need to deploy the same platform, whether it's Enterprise Linux or OpenShift or Microshift into an OT environment. So yes, it's available. And there are also like free trainings available that you can start onboarded, and you can even do your certifications and become a certified architect as well if you choose to. So yes, is the answer. Thank you for the question.
Great, thanks, Andreas. I'm being given the signal to close our Q&A session. So I just personally want to thank Patrick, Amy, Andreas, Lindy, and Arno for your absolutely fine contributions today. Apologize if we didn't get through all the questions, but we have noted all these down, so we will be getting back to you after talking to Red Hat if we've missed anybody out. So with that, let me hand back to my ARC colleague for the closing. Thank you.
Oh, sorry, I was muted. Thanks, Bob, and all the speakers for giving a great presentation. And we had lots of questions coming in, but we have no time to answer. We'll be answering it privately through the speakers. So I have an upcoming announcement for the in-person event. We have a forum organized in Asia for Tokyo, Bangalore, and Singapore. So Tokyo, Japan event is on 8th July 2025, and Bangalore, India event on 10th, 11th July 2025. Singapore event is on 7th August 2025, and we have a forum in Europe. So the European Industry Leadership Forum is scheduled on 5th to 7th May at Barcelona. And we have recently completed our ARC Annual Industry Leadership Forum at Orlando. So I would like to thank Patrick Arnold, Research Analyst, ARC Advisory Group, and also Patrick Arnold, Research Analyst, ARC Advisory Group, USA, AMISO Specialist Solution Architect, Ansible Red Hat Asia Pacific Singapore, Andres Spanner, Chief Architect, CTO, Office and Global Engineering, Red Hat Asia Pacific, is from Australia, and Lindy Sabloff, co-founder and COO, Guys AI from USA for participating in this ARC Asia Industry Best Practices webinar. And I would like to mention thanks to Garrett for the coordination and also Mr. Arnaud for joining in the Q&A session. We also thank Bob Gill from ARC Advisory Group Singapore for moderating the session. And we also like to thank all the delegates for participating in this webinar.